What's up, everyone? This is LeetCode 102, binary tree level order traversal. We've done this problem in Python, now we're going to do it in C++. My Python video was very over-explanatory. I might move a little bit faster in this video, so apologies for that, but I'll still try to explain things in case you only code in C++. So we're given the root of a binary tree, right? And we have to return the level order traversal of its node values, right? So we have to go from left to right, level by level, right? So we have this 3, right? That gets it. And every level, basically, all the nodes we add from that particular level get put in its own list. And then after we're done handling that level, that list gets put in another list, right? So for example, this 3 is its own list, 9 and 20, right? For level 2 is its own list, 15 and 7 is its own list. And that's all wrapped, and all those are put in another list, okay? So first of all, before we begin, let's handle the constraints, right? We can have 0 nodes in the tree, so that's an edge case we need to handle, right? So we're going to say, right, if root's null, then basically we would just return result, which would be an empty list. And let's make that up here. I'm going to say vector int. So result, obviously an empty list initially. If we're given an empty root node, we just return the empty list, obviously, because what would you put in there? Okay, so the way we're going to handle this is we're basically going to use a BFS, not a DFS, right? Because how would a DFS help us here, right? Like we need to go level by level. So a BFS is useful, right? Because when you're using a BFS on a tree, generally, you use a queue, right? And that helps you go level by level, right? So yeah, so I'll show you. And again, I don't want to make this video too long, so I'm gonna move maybe a little quickly, but the gist of it is really that like we're gonna maintain a queue, right? And we're gonna start with the root node, okay? And we're gonna say while there's something in the queue, we need to process the nodes in the queue, right? And additionally, when we process a node, we need to add its child nodes to the queue, right? So we would process this 3 and then add 9 and 20 so that we can keep going. But how do we basically know when to stop, right? Because remember, we're adding this 3 as its own list because it's on its own level, right? We don't want to add this 3, this 9, and this 20 all in one list, right? So how do we know when to stop for every list? Or I should say for every sub list in the list. And the way you do that is basically before you do anything, right? When you enter the while loop that says while something's in the queue, before we do anything after we enter that while loop, we're going to basically take what's the current length of the queue, and we're going to process from basically that range, right? So for example, this 3, like when we handle this 3, right, we add 9 and 20. So when we handle this 3, we have a length of 2 now, right? But initially we only have this 3. So we're going to say while something's in the loop, right? Basically, while something's in the queue, right? We're going to enter that while loop, and we're going to say, okay, what is the length of the queue so far? Or before we even do anything, what's the length of the queue? It's 1, right? So we're going to say basically for, we're basically going to say for, int I, right? I is less than size, and size would just be the queue size, which would be 1. And so basically we're only going to handle one node in the queue, right? So even if we handle this 3 and we add 9 and 20 to the queue, it doesn't matter. We're not going to handle that 9 and 20, right? Because our for loop is only going to go once, right? And so that's kind of how we're going to handle it, okay? In terms of knowing, because like I said, like because we're adding child nodes from every node we handle, our queue could potentially keep expanding and expanding and expanding, but we only want to handle some of those nodes, not all of them, because some of those other nodes in the queue could be from a level below or something, right? And we don't want to handle those for the current level we're at, right? Because then our output would not be correct. Okay, so we're gonna say, and again, initially we're just gonna start with the root node, right? So we're gonna say q.push root. Okay, so again, we're gonna say while something's in the queue, right? And this is C++, so we're going to say basically while the queue is not empty. Okay, we're going to get the size of the queue, so we're going to say int size right? And you can just do q.size in the for loop. I'm just putting in its own variable, but yeah, it's whatever. So we're gonna say level, right? And this is basically the nodes, because we're gonna handle a level, right? Like 9 and 20, and we're gonna put those in this vector of level, and then at the end, we're gonna put that in the overall list that we need, which is the result vector, which is a vector of vectors, or a vector of integers inside a vector. So yeah, a list of lists, right? So the way we're gonna do this is we're gonna make our for loop now, right? And here's where I said, like, we need to know how many nodes to handle, because like again, our queue could start expanding. So let's take the current length of the queue, so before we even do anything, and that's basically how many nodes we have to handle. Okay, so we're gonna say node, right? We need to pop from the queue. Okay, and basically if the node, right, if the node is going to have children, we're going to have to append that to the queue. But before we do that, let's just add the node to the level vector, okay? So we're going to say level.pushback, right? Node.value. Okay. Now here's basically what we do. Like if node has a child node to the left, we need to add that to the queue, right? And I don't want to make my code like too messy, a bunch of statements, so I'm just going to put on a single line. We're going to say push. Okay. Same here. We're gonna say node.write has something in it. We're gonna say push. Yeah, I don't know. My styling for C++ is not the best, so if you're like a very strict C++ programmer, I'm sorry. But I don't know. So this is the if statement, this is the for loop, and this is the while loop. So before we exit the while loop though, when we're done with the for loop, right? Like when we handle the 3, or when we have 9 and 20, when we handle the 9 and the 20, we need to take that level that we just basically created in our for loop, and we need to append that to the result variable. Okay. So we're basically putting the list in the result list. Well, they're vectors in C++, but you get what I mean. So we're gonna say result.pushback level, right? And out here, basically the end of the program. So here's where we return result. Okay. Yeah, so this problem isn't too hard. I think when you finally like grasp this problem, I think it's a little bit on the easier side of the mediums. But I mean, really what all you're doing is basically, right, you're maintaining a queue, right? Whatever. Right? Like whatever. And, you know, all these nodes in the queue, right, could end up having child nodes themselves. So basically, before you handle any of these nodes, you basically want to take the length of the queue before you do anything, which would be 4, so that you handle only these 4. Because if you add more child nodes to the queue, like how do you know when to stop if you don't have that for loop, right? You don't. So that's kind of the point of the for loop. So yeah, I mean, I think it's not too hard of a problem, honestly. There are definitely more confusing problems out there. But yeah. Yeah, basically. I mean, there are like variations of this problem, like where, I mean, in this one, you're actually taking every level and appending it to a result variable as a list, or you're taking every level as a list, appending that to a resulting list. But there are like similar problems, like for example, go level by level and print out each node, right? Like there's a bunch of different types of interview questions that might be similar to this. I'll bet maybe a little bit different, but like going level by level on a tree, like it is useful. You should know it. So yeah, just learn it, right? Not too hard. But anyways, I hope this helped, and I'll see you in the next one. Peace out.